Hi, I've done a video lately where I played a patch that I built in Alpha Forever, which featured a saxophone sound. And this is basically the same patch. I was trying to record this video in a different way before, and yeah, I didn't succeed and I don't want to restart it, so I'm trying to do it live and trying to break down this patch live. So if I play this, you can hear that this is quite the same as in the previous video. It sounds pretty acoustic and fine, for me at least. I don't know how a saxophone works at all, so bear with me. If you are a saxophone player, then don't hate me, please. Yeah, let's disconnect this patch and try to rebuild the whole thing from the ground up. So I create an output, and I need the MIDI input for sure. So I create a MIDI note node as well. And the first thing that creates a sound is the ADSR modulated. And let me copy the settings from there. So 700 milliseconds for the decay, 0.19 for sustain, and 6.2 milliseconds for release. And I'm gonna plug this into the stereo track. So we can have a listen to an ADSR. It will sound not good. Yeah, it's not good. But this is simulating the air pressure. So if you blow the instrument, air pressure is rising inside the instrument. So this is the idea behind this node. I hope this makes sense. And this is all that I know from a saxophone. And the second thing that you see is this filter here. So I place the filter here, use the bandpass output, and plug in the pitch into the cutoff modulation. And yeah, if I crank down the resonance, then you can hear that this is a sinusoid sound, and if I release the key, we have another click. So the idea is that we rescale the gate so that when the gate is high, then we have a low value for this resonance. Since the state variable filter self-oscillates when it's close to 0, and we have a fairly high amount of resonance when the gate is low. So now this will be a continuous sinusoid sound. And it is indeed. The next thing we want to work on is the bend. So we have pitch bend here, and if I create the bend node, yeah, maybe it's not a good idea to have the original patch here, so I create a designer for it and place it inside. So if I need some help, I can come back into this designer, because this way the naming is getting disturbed. So for the pitch bend, I need an input for pitch and an input for the bend. And we simply add these together. And the output is the, I call it Y. And I also want to output the unmodified pitch. And the pitch bend range is in between -1 and 1. And I want to double it so that we move it into the range of -2 and 2 semitones, because that's what I like for pitch bend. So pitch and bend. And this can go into the cutoff modulation. And now we can pitch bend. It works. And then we have legato, which is pretty important. So we take the pitch and we take the gate, and I think we also use the velocity. So I'm not sure that it's like that, but as far as I remember. And we want to put an envelope follower on the pitch and delay the gate by to the previous sample. and multiply the previous sample by the legato amount, and then this goes out, and yeah, I also want to output the unmodified pitch here as well. And yeah, the legato amount is going to be depending on the velocity. So I can put a custom function here. And as far as I remember, it's going to look like this. And if the velocity is low, then we want to have a longer legato. So let's say then the output should be like 600 milliseconds, and if it's high, then 15. As far as I remember, it should be like this. And then the pitch can come here, velocity can go there, and gate can come here. And now we can plug in this once again into the cutoff modulation, and we can play the legato. And it works. I cranked down the volume to -12 dB, and I also test that on lower velocities the legato is longer. It works. Then we have a vibrato. It will also need the pitch input, and it will also need the velocity input and the gate. So in the previous node, maybe it's better to output the gate. No, first the velocity, then the gate. So this way the patch won't be a spider web, hopefully. So we can just go like this, that pitch, velocity and gate. And yeah, the vibrato is just adding to the pitch, and the output is going to be like this. And yeah, we want to put an envelope follower on the gate. Let's give it some attack like 6000 milliseconds, which is 6 seconds, and multiply the modulator by this value. And here I'm going to use a triangle LFO at 6 Hz. And also modulate this LFO by a random LFO, and I think it was around here, like this. Actually, this should work. It's better if this is bipolar, so I double it and subtract 1 from the result. And sorry for sometimes I hit a key here on my keyboard, I don't know where, but my deck is not the most comfortable one. And I don't need the velocity. Nice. And this can go there once again. And it works. So we have the articulations ready. And I think this is until now the same as before. And we can add air to the sound, which is just white noise basically. So I call this air, and this will have an input of X, and I'm going to multiply this by something and output Y. And that something is going to be white noise, and it will be multiplied by the envelope, like this. And after the multiplication, we need to add 1 to it. Sorry, I forgot that because This way, if the white noise is in the range of 1 and -1 and we add 1 to it, then the whole thing is going to be centered around 1. And that way, if we multiply, we just add noise to the signal without mixing it properly. So this way it's like the noise is going to conform to the envelope of the original signal, if this makes sense. I hope it makes. So we can take the input and we can take the envelope's output and plug this into the output there. And obviously this is too noisy. So we need to multiply this by some scalar. And I think that 0.1 is enough. It works, okay. But this is still just a sine wave. So let's create a resonator. And it will be a very basic resonator actually. So we take the input of X, add something to it, and that's going to be the output on Y. And we will just delay the signal like this, multiply it by a coefficient and plug it back to the input. So basically this is currently a Karplus-Strong patch. We will have a delay time, we will have an input which we are going to call power or POW, and we will have an input called DMP for damping. I just create this so we have it. For the time being we only use the delay input, and we are going to make use of the power input, which is going to be the coefficient here. Alright. What I also wanted to do, no, that can come later. So I just plug in the R into the X and the output goes straight into the output. And then we can take the original pitch, so the unmodified pitch from here, and convert it to milliseconds and double it. I found that doubling the length of the cycle helps a lot. And the power is going to be the envelope itself. And since there's no damping yet, I'm not patching it in, but I think that it's going to be this once again. So it can go there. Maybe it's better to use this pitch. Yeah, it's better. All right. So I'm going to output, then let's use the pitch with the vibrato. Sorry for the messing around. We can use that for damping too, and then the patch is going to be cleaner. I'm sure that this is not the way I did the original patch, but the sound is not going to be too different. We just spare some clicks. Alright, next step, add some non-linearities, because of these instruments tend to be non-linear. So I insert a 10H distorter here and another one into the feedback loop. This is quite so this sounds like a flute now, so or something like a flute. So let's also introduce damping. I put an filter 1P, a 1-pole filter into the feedback loop. That's going to be our damping. And yeah, I can already patch this into the cutoff modulation. Crank up the cutoff modulation, this down to 0, and this is not what we want exactly, because if we want to do something really crazy here, we just add one to this 10H, and also put a gain in front of it, because if we want to scale that signal later on. and we will multiply the delay time with this. So we are going to modulate the delay time with the audio input, which doesn't sound like that it makes a lot of sense, but it should. And we can crank this down. Now the damping is a bit too much. Now we are getting there. So this sounds like a brass instrument or something like it. Nice. Let's also add some body to this, and this is going to be the magic part once again, like in my string video. Basically this is the same trick. X, output 1, output 2, and this is going to be the resonance. This is going to simulate the air while it's bouncing around inside the instrument. So I crank down the LP to 8000-ish, drive it on maximum, the size to something very small like this 006, and the decay to taste. Done. And basically this is the patch itself. There's one more thing that I've done is to do some expression, and that requires a VST parameter that I call expression. And I'm using the first VST parameter, and I can already control it. And yeah, this will go into a power node, where I take the input of the expression. I think I use the velocity also, and what do I use? I have to cheat. I don't remember anymore. So yeah, expression by the envelope, and then the velocity. I just copy paste this part here because of this is only the controller for the attack time of the envelope follower. Yeah, I know now. So let's come back here. And we have the expression, we have the velocity, and we have the envelope. So let's create an input for the envelope as well, and one for the velocity. And yeah, the velocity has a curve that was, so I changed it to a curve that was fine for my playing style. I don't know if this is right or not. And I rescale it to 616, could have done it like this as well. And then there's no need for the rescaler. And I create an envelope follower modulated, give it a bit of release because of the parameter smoothing, or I don't know. And multiply the expression by the envelope. And that comes here. And I modulate the attack time using this value here. And this is going to be the EOW. And then I can plug in this to the expression. The envelope can go there, and the velocity can come here. Like this. I try to make the patch a bit clean. Maybe I succeed, maybe not. So I plug this into the power. Something like this. It's not ideal, but somewhat readable. Yeah, this way it's better. Anyways, I can move this to the vibrato, yeah, like that, it looks better. And we need to create, we need to modify this part as well, so I create a crossfader, because this power is going to crossfade in between different values. And as far as I remember, I used a power of 0.5 when the power is low, and so 1.16 maybe if it's high. So this way, if the expression is a bit higher, then the signal is saturated a bit more than without it, and if the expression is low, then the signal is a bit weaker inside the feedback loop as well. So yeah, basically this is the patch, and this is how I made it. It's basically just a simple carpool strong patch with that works on a sinusoid signal. So it's not the carpool strong part which creates the resonances. It just modifies the sound of the sine waves, and the trick is to modulate the delay time basically. And it really creates a nice brass sound, so even without the body. This is something that's usable. Yeah. I hope this was interesting or useful, and if you like this kind of content, then subscribe, leave a comment, and share this video, or I don't know. You can download this patch from our Discord server, and yeah, see you again next time. Happy noding, bye bye.